In section 6.4, we are factoring trinomials of the form ax squared plus bx plus c by grouping. The grouping method is also called the AC method because you're taking a, the coefficient of the x squared term, and c, the constant, and multiplying those together to get a product a times c. Our strategy for factoring using the AC method is we want to find two numbers that have a product equal to AC and a sum equal to b, that middle coefficient. Then you replace bx by two terms using the new numbers as coefficients. I call that splitting up the middle term. And then finally, we factor the resulting four-term polynomial by grouping. Let's factor the following trinomial by grouping using the AC method. We have 12y squared plus 17y plus 6. This is called the AC method because our polynomial is written in the form of ax squared plus bx plus c, and a is the leading coefficient and c is the constant. So we're going to take a times c, which is 12 times 6, which is equal to 72. Now we want to find the pairs of factors of 72 that will add up to the middle term b, add up to 17. So we want to find two numbers whose product is 72 and whose sum is 17. So let's list out all the pairs of factors of 72. 72 is 1 times 72, 2 times 36, 3 times 24, 4 times 18, 6 times 12, and 7. Eight times 9. Sorry about that. Now out of all these pairs of factors, we could also consider the negative 1 times negative 72, negative 2 times negative 36, and so on. All of those would equal a positive 72. We want to find the pair of factors that gives you that middle term of 17. And in this case, we have 8 times 9 equals 72, and 8 plus 9 is equal to 17. So we have found our two numbers, 8 and 9. Now we're going to write 17y using the factors from the previous step. So one way to write 17y is to write it as 8y plus 9y. And now we can factor this polynomial by using the AC method. We take our original polynomial of 12y squared plus 17y plus 6. We're going to split up that middle term. The first term is going to stay a 12y squared. The last term is going to stay a plus 6, but that middle term, we're going to write it as plus 8y plus 9y. Now we have a polynomial with four terms that we can factor using the grouping method. I'm grouping the first two terms and the last two terms together like we did in the previous section, and we find the GCF for each group. The greatest common factor of 12y squared and 8y is 4y. So I'm going to factor out the 4y, and then the greatest factor of the last two terms of plus 9y plus 6 is plus 3. And I factor out a plus 3 because this sign here is a positive. When you factor out 4y from the first two terms, you are going to have 3y plus 2. When you factor out 3 from the last two terms, you're going to have 3y plus 2. Now we've got these two large groups, and notice each large group has that common factor of 3y plus 2. We have 4y times a quantity 3y plus 2 plus 3 times a quantity 3y plus 2. So in factored form, we're taking out that 3y plus 2 that they both have in common, and then what you would have left is 4y plus 3. So the answer to factoring that trinomial ax squared plus bx plus c using the AC method or the grouping method Now let's check to make sure that we have the right combination of factors. 3y plus 2 times a factor of 4y plus 3. Using the FOIL step, 3y times 4y is 12y squared. The outer 3y times 3 is plus 9y. The inner plus 2 times 4y is plus 8y. And the last is plus 6. By combining the middle terms, we get 12y squared plus 17y plus 6, which was our original polynomial. To factor 10x squared plus 9x minus 9 using the grouping method or the AC method, we recognize that this is in the form of ax squared plus bx plus c. This is called the AC method because we're going to multiply a times c together, a being the leading coefficient and c is the constant. In this case, the a is 10 and the c is negative 9. So 10 times negative 9 is negative 90. Now we want to find the two numbers whose product is negative 90 and whose sum is positive 9. Just realize that there is a mistake here on the handouts. If you're following along, make that correction. You want to find two numbers whose product is negative 90 and whose sum is a positive 9. And we want to write positive 9x using the factors from part A. And notice here that our original trinomial, the middle term was a positive 9x. So our factors of negative 90 is negative 1 times 90, negative 2 times 45, negative 3 times 30, negative 5 times 18, negative 6 times 15, negative 9 times 10, negative 10 times positive 9, negative 15 times 6, negative 18 times 5, negative 30 times 3, negative 45 times 2, and negative 90 times 1. Now, it's not necessary to list out all of these because you want to find just the one pair that will add up to positive 9. And we can see that this pair of factors, negative 6 and 15, those are two numbers whose product is negative 90 and the sum is a positive 9. So we're going to write positive 9x as the two factors from part A. So we can write positive 9x as a negative 6x plus a 15x. In using the grouping method, we take our original trinomial, 10x squared plus 9x minus 9, and we split up that middle term. By using the AC method, we found that that middle term can be written as a minus 6x plus 15x. So the first term, 10x squared, is going to stay the same. The last term, minus 9, is going to stay the same. But that middle term will write as a minus 6x plus 15x. Now you could write it as a plus 15x minus 6x, and you can still do the method factoring by grouping. Now notice that our polynomial is written in 4 terms, so we have 2 groups. We're going to separate those 2 groups and find the greatest common factor for each group. In the first 2 terms, we see that the greatest common factor of 10x squared and 6x is 2x. And in the second grouping of the last 2 terms, the greatest common factor would be a plus 3. By factoring out the greatest common factor of 2x from the first 2 terms, we get 5x minus 3. And factoring out a 3 from the last 2 terms, we get 5x minus 3. So then we can say we have 2 large groups, and the common factor here, you can see out of the 2 large groups, is that factor of 5x minus 3. And what we have left over when you factor out the 5x minus 3 from both of those 2 large groups is the other factor of 2x plus 3. So our answer to factoring that trinomial using the AC method or the grouping method, we get the factor 5x minus 3 times the factor 2x plus 3. We can use a FOIL method to check our answer. First, 5x times 2x is 10x squared. The outer is plus 15x, the inner is minus 6x, and the last is minus 9. By combining the middle terms, we get 10x squared plus 9x minus 9. So that's our original polynomial. which means that we know that our two factors are correct. We will factor by grouping, beginning with 8x squared plus 18x plus 9. Using the grouping method, also called the AC method, we're going to multiply AC together, where A is equal to 8 and C is equal to 9. 8 times 9 is 72. Now we want to find the pair of factors of 72 that will add up to positive 18. 72 has a lot of pairs of factors, so we're going to list them out. We can start with 1 times 72, 2 times 36, 3 times 24, 4 times 18, 6 times 12. Okay, I'm going to actually stop right there. Even though there are more pairs of factors, I want to find the pair that will add up to that middle term of 18x. And 6 and 12, if you add it together, will give you 18x. So we can write this trinomial, keeping the first term 8x squared and the last term 9, and splitting up that middle term. 18x can be written as a plus 6x plus 12x. Now we can factor by grouping, looking at the first two terms in the first group and the last two terms in the second group. Taking the greatest common factor out of 8x squared plus 6x, that greatest common factor is 2x. When you factor that out, you'll have left 4x plus 3. The greatest common factor of the last two terms is plus 3. When you factor that out, you have 4x plus 3. Notice that these groups have a common factor of 4x plus 3. 4x plus 3 is one factor, and when you take that out, what you have left is the 2x plus 3, which is the other factor. So the trinomial in factored form is one factor of 4x plus 3 and the other factor of 2x plus 3. It doesn't really matter what order those are written in, as long as you are multiplying those together, then we have the correct ones. And as always, we want to check our work. By using the FOIL method, 4x times 2x is 8x squared. The outer is plus 12x, the inner is plus 6x, and the last is plus 9. By combining the middle terms, we have 8x squared plus 18x plus 9. That was what we started off with. Let's look at example D, 6x squared plus 7x minus 3. Using the AC method, where A is equal to 6 and C is equal to negative 3, we want to multiply A and C together to get 6 times negative 3, which is negative 18. We're going to list the pairs of factors of negative 18 until we find one that equals 7. We have negative 1 times 18, negative 2 times 9, and you can continue further, but we have found the pair of factors that does add up to that middle term of 7. So using the factoring by grouping method, the AC method, the first term is going to stay 6x squared. The last term is going to stay it's negative 3. That middle term, we're going to split it up into two factors, the first being minus 2x and plus 9x. And then using the factoring by grouping method, out of the first two terms, you can factor out a 2x. And out of the last two terms, you can factor out a 3. And we're going to factor out a plus 3 because this sign is a positive. When you factor out the 2x from the first two terms, you're going to have 3x minus 1. And when you factor out a 3 from the last two terms, you also get 3x minus 1. Notice the two groups have this common factor of 3x minus 1. So 3x minus 1 is the first factor. And then what you have left, you have the 2x and the 3, which is your other factor, 2x plus 3. Our answer to factoring that trinomial using the AC method or the grouping method, we get one factor of 3x minus 1 and the other factor of 2x plus 3. We can check by using the FOIL method. The first is 6x squared, the outer is plus 9x, the inner is minus 2x, and the last is minus 3. By combining the middle terms, we get 6x squared plus 7x minus 3. That's what we started off with, so we know that we have the right factors. In example E, we have 7x squared minus 19x minus 6. Using the AC method, we can multiply A, which is 7, times C, which is negative 6, to get negative 42. And we want to list the pairs of factors of negative 42 that will add up to the middle term of negative 9. The pairs of factors of negative 42 are negative 1 times 42, negative 2 times 21. Well, I see negative 2 times 21, that would give me a positive 19, but we want a negative 19. So let's try negative 21 times a positive 2. That's the pair of factors that when you add them together do give you negative 19. So using the AC method or the grouping method, the trinomial can be written as the first term is going to be the same and the last term is going to be the same, but that middle term we're going to split it up into two terms, and negative 19x can be written as minus 21x plus 2x. And then using those two groups to factor the greatest common factor out of each of those terms, we can factor out a 7x from the first two terms, and we can factor out a plus 2 from the last two terms. When you factor out 7x, you'll be left with x minus 3. And when you factor out 2 from the last two terms, you'll be left with x minus 3. So notice the common factor of x minus 3, and the other factor would be 7x plus 2. This is what the two larger groups had that common factor of x minus 3, and what was left over, the 7x plus 2, is the other factor. So you can check your work by using the full process. The first is 7x squared, the outer is plus 2x, the inner is minus 21x, and the last is minus 6. By combining the middle terms, we get 7x squared minus 19x minus 6. Let's factor 4x squared minus 12x plus 9 using the AC method. AC, A is the coefficient of the leading coefficient, which is 4, times 9, which is the constant, AC. 4 times 9 is 36. And the pairs of factors of 36, you can list them out. There are quite a few. And you can find that the pair of factors that will add up to that middle term will be negative 6 and negative 6. Negative 6 plus negative 6 equals negative 12. And that's what we're looking for. In this method, the first term and the last term stay the same. We split up that middle term. Negative 12x can be written as minus 6x minus 6x. And then we factor by grouping, looking at the first two terms and the last two terms separately. We can see we can factor out a 2x from the first two terms, and you can factor out a negative 3 from the last two terms. And the reason why we factor out the negative is because this middle sign here is a negative. When you factor out the 2x from the first two terms, you get 2x minus 3. And when you factor out the negative 3 from the last two terms, you get 2x minus 3. So notice the two big groups have that common factor of 2x minus 3, and what's left over when you factor that out is 2x minus 3. So we have 2x minus 3 as one factor and 2x minus 3 as the other factor. This problem can also be written as 2x minus 3 times the quantity squared. This is one of those perfect trinomial squares where the factors end up being the same. You can check your work by using the first, outer, inner, last to get 4x squared minus 6x plus 9, or 4x squared minus 12x plus 9. So our answer can be written as the quantity 2x minus 3 all squared. In example G, we're going to continue to use this AC method where A is equal to 6 and C is equal to 5. We're going to multiply 6 and 5 together to get 30. And then we want to list the pairs of factors of 30, and we want to find that one pair that will add up to negative 17. And that pair of factors will be -2 times -15. The product is 30 and the sum is -17. The AC method, we keep the first term and the last term and split up that middle term. The -17x we're going to write as -2x minus 15x, and then factor by grouping. The two large groups here, the first two terms have a common factor of 2x. The last two terms have a common factor of -5. And again, that's going to be negative since that middle sign is negative. When you factor out 2x from the first two terms, you get 3x minus 1. Factor out 5 from the last two terms, you get 3x minus 1. So our factors, we have 3x minus 1 as one factor, and the other factor is 2x minus 5. This is how we write our answer, and you can check your work using the FOIL step. 3x times 2x is 6x squared. The outer is minus 15x, the inner is minus 2x, and the last is plus 5. By combining the middle terms, you get 6x squared minus 17x plus 5. In example H, we're going to factor out a GCF before we go through and use the AC method. I've noticed that all of these numbers are multiples of 5, so I can factor out the GCF of 5 before working through the AC method. When you factor out the 5, you will have 4x squared minus 3x minus 10. Now this trinomial 4x squared minus 3x minus 10 can be factored using the AC method. So the AC of the trinomial in the parentheses of 4x squared minus 3x minus 10, the A is equal to 4 and the C is equal to -10. The product of 4 and -10 is -40. When we list the pairs of factors, we want to find a pair of factors that will add up to that middle term of -3. That pair of factors is -8 and a +5. So we can split up that middle term. Don't forget to keep that greatest common factor out in front. So that first term stays as a 4x squared. That last term stays as the -10. We're splitting up the middle term into a -8x and a +5x. And then within the polynomial in the parentheses, we're grouping the first two and the last two terms. Don't forget to keep that 5 all the way out in front. The greatest common factor of the first two terms in the parentheses is 4x. The greatest common factor of the last two terms is +5. When you factor out 4x from the first two terms in the parentheses, you have x minus 2. And when you factor out 5 from the last two terms in the parentheses, you get x minus 2. So we have 5 as our single constant factor out in front. We have a factor of x minus 2 and a factor of 4x plus 5. Okay, remember that the x minus 2 is what they both had in common. You factor that out. And the 4x and the +5, what's left over, is one of the other factors. You can check this by using the FOIL and then multiplying that result by 5. The first, outer, inner, last is 4x squared plus 5x minus 8x minus 10. Combining the middle terms, you get 4x squared minus 3x minus 10. By distributing the 5, you get 20x squared minus 15x minus 50. That was our original problem, so we know that we have found the correct factors. In example I, we have 45x to the third plus 45x squared minus 50x. Before using the AC method, we want to factor out a GCF, a common factor. In this case, it is 5x. When you factor out that 5x, what you have left is 9x squared plus 9x minus 10. Now with the trinomial inside the parentheses, we can use the AC method, where a is equal to 9 and c is equal to negative 10. 9 times negative 10 is negative 90. Listing the pairs of factors of negative 90 that will add up to that middle term of plus 9x, we find that pair of factors would be negative 6 and positive 15. The product is negative 90 and the sum is positive 9. So we keep that greatest common factor outside, and we're going to split up the middle term in that trinomial. The first term is 9x squared and the last term is negative 10. But that middle term of plus 9x, we're going to split up into a minus 6x and a plus 15x. Keep that 5x way out in front, that greatest common factor, and then the polynomial inside the parentheses we factor by grouping. The greatest common factor of the first two in that group is 3x, and the greatest common factor of the last two terms in the parentheses is 5. When you factor out the 3x from the first two terms, you get 3x minus 2. And when you factor out the 5 from the last two terms in the parentheses, you get 3x minus 2. So we have 5x is our greatest common factor. We have 3x minus 2 is the common factor inside the big parentheses. And the other factor left over is your 3x plus 5. And you can check this by using the FOIL method that this is the correct answer. Don't forget that 5x factor out in front that you'll end up multiplying by. First outer inner last, you get 9x squared. 9x squared plus 15x minus 6x minus 10, and then 5x times combining the middle term, the trinomial in the parentheses becomes 9x squared plus 9x minus 10, and then by distributing that 5x, we get 45x to the third plus 45x to the second minus 50x. Let's look at example J. Before factoring this, we should put the polynomial in order of descending powers. So we can write this as 6x squared plus x minus 15. There is no greatest common factor we need to worry about here, so we can go straight to the AC method. The a is 6 and the c is negative 15. So 6 times negative 15 is negative 90. We want to find the pair of factors of negative 90 that will add up to the middle term. And that pair of factors would be a negative 9 and a positive 10. So in the AC method, our first term stays the same and the last term stays the same. The middle term is split up into a minus 9x and a plus 10x. We factor by grouping the first and last two terms. The greatest common factor of the first two terms is 3x. The greatest common factor of the last two terms is plus 5. When we factor out the 3x from the first two terms, we get 2x minus 3. Factor out the 5 from the last two terms, we also get 2x minus 3. The 2x minus 3, you see that we have that in common, so that is a factor. And the other factor is what's left over, and when you take that common factor out to get 3x plus 5. We can check this solution by using the FOIL step. First outer inner last is 6x squared plus 10x minus 9x minus 15. Combine the middle terms to get 6x squared plus x minus 15, which is what we started off with. In example K, the trinomial is 10z squared minus 12z minus 1. Let's begin using the AC method, where a is equal to 10 and c is equal to negative 1. The product is negative 10. Now we list all the pairs of factors of negative 10. We have negative 1 times 10, negative 2 times 5, negative 5 times 2, and negative 10 times 1. Now the problem here is that none of these pairs of factors will add up to that middle term. So in this case, we can say that this polynomial is prime, which means it cannot be factored.